Okay. Hey everyone, happy Monday. Hope you're having a good one and hope you're ready for the next live coding lesson. And if you're new here, let me explain what it's all about. So I'm a code newbie, which means on my example, you will actually um, learn or see how the learning process looks like, the learning of the new programming language, learning to code in AskQL, which is a new programming and a query language. And yeah, this is my 10th lesson. So fingers crossed for today. And I think today we're gonna play with some new API, but we'll see. That's what I know for now. And yeah, I'm a student, no coding background. I have more graphic design background. Never really had to program anything, but yeah, a few weeks ago I started to learn programming, and yeah, my teacher, Martin Hagmeyer, is my teacher, and he's a very skilled developer or software architect, if you will, with previous experience in Facebook. So yeah, and he's right here with me. So welcome, Martin. Hello.
Hello everyone, hi Marta.
Hello. So I'm ready. So just say what I have to do. I'll try my best to accomplish the goal.
Okay, so as you remember, last time, 1 week ago, we played a little bit with Star Wars data. It was actually the first time that we ever pulled data from, outside the playground.
Yeah.
This is something that we got from internet. We used the fetch mm, function to do it. And so we did some simple sample stuff, like we went through a list of some like Star Wars people and heroes who take part in the movie, and we looked for the ones that were the highest or the shortest.
Yeah.
Right.
Yeah.
Okay. So for the next step, like can you how did you find that? Was that interesting? Was that difficult? What was your impression from last week, so that we
Yeah.
know where to
It was
go?
it was challenging. I mean, it's like if you're asking me questions, I know what you're asking for, but I like either don't know how to approach the problem right away, or I don't know how to actually use the syntax in the correct way and how to write the command, if you will, to get what I want. So I just get stuck at times. But I'm trying. Oh, is my internet connection good? I hope,
Yeah,
because
I think
I
so.
everything froze for a second, so I don't know. I hope so. Um, hmm,
Yeah, so it sounds like it would be useful, I think, to do a little bit more work around those subjects. Uh, like fetching data, filtering data, just browsing through it and making something useful with it is actually most of work these days. The programming, like we program a lot of system integrations, system applications that displaying data, accepting data, sending data, and stuff like this. So really, what we do is a very like a fundamental mm, uh, thing with programming, and something that you're gonna use often as a programmer. So it's natural to to feel a little bit, overwhelmed by this at the beginning. But I'm sure that, with taking small steps, you're gonna find it more and more, basically understandable and something that makes sense. And also, like, there's so many, there's so many like those interesting problems about the data that are, difficult to really answer and in a different way. Like, so we look like at height of Star Wars characters. This is not the kind of information that you're gonna find easily just by Googling. This is something like called data mining. Obviously, like the data mining usually is done with like a really like huge data set, which is like gigabytes of data. But here, like we don't, our data is not so large, but if you have like 300 characters, you know, you're not gonna like copy paste that to Excel and use that, right? It's not gonna be, it's not a viable option because it's hundreds of objects. You're not gonna like browse through them manually. That's also not gonna work. So I feel like we're touching on like doing things with computers that perhaps where we are like AskQL is a tool, and you only need the tool if you actually need to do something with it. And I'm hoping that what we starting to show now like makes sense, like opens up this maybe like a window in head which says, oh really, like if I need to do something like that, here's a tool that I can use, right?
Mhm.
and and
Right.
like the hundreds and thousands different APIs on internet, that
Yeah.
allow you to pull data from server that, on pretty much any subject, and most of it is open. You don't even need to say who you are. It's just like it's like an open book. You can read from it, you can compute on it, you can do whatever you want. And I think this is just amazing because it's
Mhm.
just like
Yeah. Also, if you're mentioning data, it's very important to store data in the same unit and don't mix centimeters and meters, because there is no way R2D2 is the smallest character in Star Wars, and there is no way Lord Vader is the highest.
yeah.
Okay, we have also Yoda, and
I know.
and we
It
keep
was
this
bugging
kind
me
of
too. Yeah, I know,
results.
I know,
Yeah.
I know, I know. Yeah, and it's interesting that you mention it because, like, let's take a look again at the I think at the API and see. Like, let me share my screen
Okay.
uh, a little bit to sort of like, uh, yeah,
Just.
right. So this is the uh, the API we're talking about, correct?
Mm-hmm.
Yeah.
Yes.
So it is not as well documented actually as you might wish. There are some inconsistencies in it.
Mm-hmm.
For instance, like if you just write, so here, what I do here is like, you can imagine like this being a very small playground, but only for the Star Wars API.
Yes.
So this is something you can type in part of the address, and it's gonna respond with the data that sort of like lives at this address, right? So
Mm-hmm.
as you can see, like here, we got an an object of data which has like different keys. So we can know from this that the count is 82, which uh, probably means that there is 82 different answers to our question. But actually, if you take a closer look, you get results, which is a list. You see, but this is not 82 results. This is just 10 actually. So
Mm-hmm.
even though like in the entire people data set there is 82 characters, we only got we actually only got 10. And why is that? So this has to do with paging. It's called paging. So you're if you request a big set of data, you're likely not going to get everything at once, but it's gonna come in pages. So what we actually were using for our filtering was just a single page of it. So that's why the Yoda didn't come up, because he's
Oh,
just not included on the first page.
okay.
Yeah. So here is how you provide the page information. You need to add this question mark. Question mark is something in the internet address which divides the address into two parts. The first part is the actual, the location, and the second part after the question mark are the parameters. These are called URL params for it.
Yeah.
So this is just like you can think of it like a function argument, but it has a name and it has a value which comes after the equals sign. So here we're saying I'm going to want to fetch people with argument page equals to, right?
But what if I want to search for the highest character within the whole data set, not within, page by page?
Yeah, so there is a couple ways to. So ideally, the API would allow you to get all of that at once. So I'm gonna guess right now, because if there is page, sometimes there is also limit argument. I didn't read that in the documentation. I don't know for sure. Just let me try that. And the limit, no, yeah, the limit did not work because we still got 10. So it seems like this API is not really that flexible, you see, because it sort of like forces you to go page by page, unless maybe in the documentation we can learn more about it. But as an engineer, if your job is to integrate with the Star Wars API, this is what you're gonna be doing a lot, just figuring out this like API, and this can really vary from server to server. So this can actually be much different. This one happens to follow the REST pattern. Whenever you see like this sort of like people/1 or like people/1/ starships or whatever, this is REST. This is like every resource has its own address, and they can get more sort of like specific and more complicated just by using those addresses here. So this is REST. This is called REST. But REST is really just like a set of ideas, set of rules around creating APIs. The APIs themselves can really work however they want. And unfortunately, like this means that with every new system integration, you're gonna need to go through, a long documentation to figure it out how it works. Just like So this is just to give you a little bit more context about this this sort of thing. So it seems to me that we actually, let's see, people. All right, page. No information on page. Yeah, I really don't want to spend actually too much time on this. I can see, okay, the search works. You see? So there is something like search, so that's good. We can play with this a little bit. Right. Okay. So let's go back. Introduction. Yeah. Okay. Let's go back. Yeah, okay. Let me. Okay. Yeah. Sometimes this is just easier. Has to do with the usability. I'm usually clicking on the logo takes you back to the homepage, but it doesn't work like this here. Never mind. Okay, so people search R2D2. Okay, so here you see like our result is different. We only got one count. There is no next. There is no previous, and here are the results. So seems like the searching works. It found the Artudito character, which has 96 of height. But if you look for Yoda,
Yeah.
it's 66, so it's shorter. Yeah, you were right. You were right. But yeah, Yoda has ID 20, so he is included on the second page.
Okay, so if we didn't give the page number, it was only searching within the first page, and
Yeah,
that's it.
yeah. If you do this, so here is how we got the data initially from this server. We only use this address,
Yeah.
and that by default uh, is the first page. It's not the whole thing. It's the first page.
Is there a way to tell it like go search in the whole data set, not page by page?
Uh, I actually don't think so, because processing a so imagine that, like, imagine like there were 10,000 people in the people data set. So if you had a server that allows anyone to just get like a data dump of 10,000 people, that would be really like resource consuming for the server. Like, the server would not be able to handle too many of those requests, because it just like makes so much work for it to transfer uh, a lot of information over to that server. So what happens usually is that the APIs are limited. They are limited not overwhelm the server. There are different limits on the API, including like the limits that you always need to provide a page, or you always limit it to a page, so that the server is not overwhelmed by the requests. But it also means that if you are the client, if you want to get information from it, you're gonna need to figure it out how to do it. And this is why system integrations are actually difficult, because you need to just solve all of those small problems, such as like, how do I get the entire data set of people to do my computation.
If they had asked VM, though, it would not be a problem, would it?
Yeah, it would be much easier. It would be much easier, because like the idea about the AskQL is the following, right? That you have the computing environment like we do here, and this computing environment can run programs. So if your program happen to compute a certain value, like you remember, like we had. Let me just quickly look up the values that we had here, just for the friends, right? Friends is something very specific to the playground. It's not the thing in AskQL. It's a value that this server exposes using AskQL, correct?
Yeah.
So the playground server, it has the friends data set, and the Star Wars server has the people data set. You see? But the Star Wars server only allows me to access one page of the people, and that's it. It doesn't really, it's not flexible at all. It's very simple, very simplistic. And this one can run can run arbitrary programs on it. So if I'm only interested to get like the first name, and uh, and just like do something crazy, just like I'm gonna take first friend. So friend square bracket 0 is gonna be the first friend. I'm gonna take its first name. So this is the first name of the first friend, and I'm gonna concat it. So just join together with. Oh, I can actually use colon here. It's gonna be easier. I'm gonna join it with the second friend's last name. And this thing is evaluated by the playground server. So instead of me only saying, give me the first page, I can give it like a recipe of what is it that you need to do with your data to come up with a result that's interesting to me. And it does just that, because it's much easier for the Playground server to make computation on friends, given that it's its own resource, it's its own value, than it would be for me. Because if I want to do computation on people, then I need to first transfer it over to me, and then compute it on it. If I send the program to the Playground server, I don't need to transfer the friends over. I'm never concerned with that. I only concerned with the first name of the first guy and the last name of the second person. So that's the difference.
Mm-hmm.
Does that make sense?
Looks faster and easier and more user friendly.
Yeah. Right. Okay. So in that case, let us play a little bit with the. So my idea is a little bit. So my idea for today, it builds on the lesson we had previously. So maybe it's gonna be an opportunity for us to exercise a little bit more on it. I would like for us to actually access all of those. It's gonna be 9 pages, because there is 10 people per page. There is 82 in total. So let's transfer the entire people data set into the Playground and do something with it here. So you get an idea of what's going on actually, and how to solve those problems. So the problem we're solving today is, how do we get the entire people data set over to the Playground and not just a single page?
Okay, I can
Okay.
try that, but
Okay, so let me give you some tools that I think is gonna be useful. Okay,
mm-hmm.
right. So the first tool is the first tool is gonna be the while loop. We talked about the loops already. You remember, so we had this example, like let array like 1, 2, 3, 4, and we had uh, okay, array and positive numbers. Let's say a very simple loop that's gonna compute how many positive numbers are in array. Like we had something like this. So we did that by doing for a loop. So we said, okay, there is something that I'm gonna need to do for every item in the array, and here is how I do it. So we did for let I, or just let's say element of array, and here inside those curly braces, you can say, here is what I'm going to do with each element, right? So for every element, we actually want to see if it is positive, and if it is, then we need to increase this counter. And after the for loop goes over the entire array, this will be equal to the number of positive numbers in the array. Correct?
Yeah.
Okay, makes sense. Nice. So if yeah, element, I guess more than 0, then positive numbers plus 1. Okay.
Mm-hmm.
Yeah. Nice. So we got 3, and if you add another number here, we got 4, and if you backtrack, it's 3. So it seems like it works. Uh, yeah, that's the for loop. So you remember that one, right?
Mm-hmm.
Okay. So there is one. So let's leave it here. There is one additional loop called the while loop, and this one is actually more basic, more simple, but it's just like it's used a little bit different because the while loop has a condition inside. Condition. Yeah. So this condition says whether the loop should continue or not. So if I say while true and just like some operations here, this piece of code will run forever because the condition is true. So it's always true. I mean, it's always gonna run. Always.
Yeah.
Yeah. Okay. So as you can see here, if you run it, we surely go over the steps limit. Right? Yeah. So here is an example like why when the while is useful. Like imagine that we wanted to know what is the highest number that squared is below 100. So in other words, the question is what uh, if you square a number, like if you go n times n, this is the n squared, right?
Yeah.
So the question is, what is the highest possible n, so that the n squared is still less than 100?
9.
Yeah. Okay. What if I do this?
Oh.
All right. Okay. Just wanted to get the concept here to show you like how is it useful. So like to answer this question, like let's start with n equals 0,
Mm-hmm.
and let's keep increasing the n until it's not until the condition is not met anymore. So we just need to say n times n, and again, like this needs to be in its own brackets because this is a different operation, and has to be lower than 4.825. So as long as this condition is met, then this will run again. Do you know what we need to do inside the loop?
It has to start with 0 and then compare to 4.825.
Yes, it starts with 0 and it says while n squared is below 4,825, then do something. And this something is going to be increasing the n. So here is how it's going to work. It's going to first set n to 0. Then it's going to check if this n squared is below this special limit number. And if it is, it's going to increase it and then repeat the process. So we're going to set n to 1 and then check the condition again. And it goes like this until n is so large that when you square it, it goes over the number.
Mm-hmm.
Yeah.
Okay.
This sort of thing would not be possible with the for loop. So this is why we need it. This is why the while is special. So whenever you have pretty much the way to think about this, if you have a loop scenario where you need to repeat some operation and it's not related to an array, then perhaps the while loop is the while loop can help here. Or you could use recursion also, but this is just like I thought this is important to mention, so you know this as well. The while loop really takes one thing, just the condition and the operations that need to be looked. Okay, let's take a look. Oh, it says 70. Interesting.
Oh.
So let's check. If let's check. So let's return more information. So let's return the n and also the n squared, so we can compare if that was actually true. Oh, interesting. So we got 70, and when you square it, it's 4,900. So it's actually more than that. And that makes sense because as soon as the n was, above the limit, the loop stopped.
Oh, okay. So
Yeah.
the first time it hits false, it stops. Okay, but after
Yeah.
that, all right.
Yes. The first time it sees false, it's gonna stop.
Mm-hmm. Okay.
Yeah. So that's the while loop. So that's the while loop in it. Okay, so this is something that we're gonna keep repeating. I just wanted to put it out there. Okay, right. So let's go back to this API and to the problem that we had. So again, we're gonna use this and plus people, and we're gonna fetch this into the right. I'm gonna create a new one. Yeah. Okay. Fetch. Fetch, as you remember, very simple. You just copy paste.
Single
Yeah.
quotes. Yes.
And the address here. Yeah, it gives you the answer. So again, as you can see, and we didn't realize that before, but we just get 10 items. You see, number 10 is here. Here is 9. Here is 8, and 1 is at the beginning. Here's 1. Another way to verify that is to do a little bit of data science in it, because as you can see, there is different values, and this is an object, so we can say, okay, const. Let's call it API answer. So we can use it now. The API answer dot count this value, right?
Right.
Yeah. So you run it. Surely you get 82. That's okay. So we got the count, the number, the address. Previous is nothing, and results is a list. So let's do results. Oh, okay. So now we only get this list. But the question is like, how long is it? So do you remember how to check the length of the array?
Oh man, not really. No.
Okay. So let's take a look at the available resources, because computing size is going to be a resource, because this is like a mechanism that computes something, so it has to be a resource, not a value. So let's take a look at the available resources, and we have different sections here. So list section has something called length. Interesting. Okay, so let's try that length. Okay, it's 10.
Yeah.
Nice. Okay, so it's actually 10, not 82, and that's and this is a problem that we will be solving here, and I'm gonna okay. So in order to solve this problem, we need to learn how to create bigger arrays from smaller arrays first. So let's imagine that we have array 1, which is 1, 2, 3, and array 2, which is 3, 4, 5, and we want to create a array 3, which is basically adding those two together, right? So we basically want to create this something like this.
Yeah. Can you use concat for that?
Yeah, that's what I was wondering. Okay, let me see. Const. All right. Hmm. Yeah, I can, but it's it didn't quite work like as expected because this is a string, not an array anymore, right? Let me see because I don't quite. Okay, that's not push. Is it join? I don't quite. No, it's not join. Okay, interesting. Let's take a look together because that might be.
Mm-hmm.
Not even sure if we have this ability to join arrays together. That will be interesting because if we don't, then
We
we
have
we
to.
will not be able to create the entire list. Yeah. Okay. Interesting. So let's change the so let's change our idea a little bit. So instead of creating a one large array, we're gonna go page by page
Okay.
we're gonna go page by page to get the answer we want. Okay, so what is it that we're looking for today? Maybe the heaviest one.
No, we have to find the tallest one still.
Oh, okay. The actually tallest one.
We
Okay.
have to prove Wookiee is the tallest, the high, the tallest one, the tallest character.
Yeah.
Maybe it's not a person, but a character. Or we can find the smallest one, which is Yoda, in fact.
Yeah, makes sense. Okay. So in order to do this, we need to be able to go through the entire data set. We cannot just get all the pages and join it together because there is no join operation in the playground. So instead, we're gonna go page by page and look for an answer within the pages. Okay, so let me solve that while explaining what I do, and then I'm gonna give you a similar exercise so we can do that together as well. Okay.
All right.
All right. So the first thing that we need to see is that when the API answer has the next key, and the next key is very useful because it gives you an address that you need to follow to get the next page.
Yeah.
Yeah. So initially the next page is actually the first page. Yeah, like this, right? So so I could just reuse that actually. I could just say next.
Why is it the first page? Like, are we now on the page 0 or something? Or
Uh, so why is it called? Why is it one? Yeah,
yeah, why the next page? I mean, if we are on the page 1 right now, the next page would be page number 2.
Yes, I believe we are currently at page 1, and we can also verify that by running this. Yeah. Now we are fetching this address, right? This is just an address. This is just an address. It's just like, yeah, if you just like browse people here, you get this bunch of results, and they say that the next bunch is at the page 2. So I mean, it's just like yeah, you do page 2, you got the previous at page 1 and the next at page 3. So that's how you can know that the first batch is actually page 1.
Okay.
This is maybe a little bit of hacking, because we ideally we would read that from the information, but this is stuff that you can figure out, I guess, just by playing with the technology.
Mm-hmm.
Okay, so this is wait. So this is the first page. So we need to fetch that first page and do something with the results. So just for the first page. Okay, so let's say that we have.
Okay. I thought the next was called, like, the URL of the next page was had one at the end of the URL. Just didn't see it was number 2, so never mind.
Yeah. Okay. So I'm gonna have something called I'm gonna have something called best person. Yeah. And initially this is and initially this is gonna be null, or yeah, null. Let's call it null. It's empty.
What
And
does the person mean?
The best person is gonna be, so now it's gonna mean the highest person. Okay, maybe this person. Okay. So one example way to do it would be like to say that the highest person is the first person of the results 0, right? Highest person. You see, we just got we just got the first result because I fetched the next page, which was the first page, and then I got the first result of it. So currently my program returns the first person of the first page.
Mm-hmm.
Okay. Yeah.
Yeah.
Right. Okay. So let's clear this up a little bit. We're gonna say results are API answer results, and the highest person is this one. Okay. Right. So we still have the same program. So now we want to so now actually we want to go over all the results to find the one that's the highest. And I think the easiest way to do it is to use the for of loop, because we need to compare all the elements.
But like, why do you have this highest person and highest person equals results, and then you have 0?
So this was just to so this doesn't work yet. So this doesn't solve our problem yet, and I just set results 0 to get one result, and to show you that the highest person is the object. It's not the name, it's not the height, it's not any specific thing. It's the entire object. So that was my idea.
Okay.
Yeah, I think it's gonna be more clear as we go on.
Mm-hmm.
Okay, so the next step is gonna be actually going over the list. So for const person of results, we need to see if so first thing that can happen potentially is that the highest person is null. So that happens at the beginning. Like, so here's us going through all the results, and one thing that can happen is that the highest person is null. Is not I mean, it's not set yet because this is the first one that we just going to see, you know. So we say highest person equals person, because if we don't know, if we have no candidate for the highest person yet, this person that we see right now is going to be the candidate. Otherwise, if the highest person was someone, then we need to check if highest person height to int. Remember, we need to do this casting, because by mistake, I think this returns a number like string, and it's a number, so we need to change that. So if the highest person height to int, maybe let's do it like this: highest person height, or like the highest height. Okay, maybe highest. Oh, this actually doesn't help that much with readability, so I'm gonna leave that. So if the currently highest person height is less than the person height to int, so this means that we have thus met a person that's higher than what we thought was the highest person so far. So what we need to do right now, we need to say that the highest person is actually that one. Does it make sense?
Yeah, I'm gonna have to go step by step from the beginning because I think I'm lost a little bit. But let's just.
Okay, no problem. Just let me just verify that this actually does what it's supposed to. Okay, I got Darth Vader like before. Okay, so we good there. Okay, let me walk you through this again.
Okay, so setting the highest person, okay, and we are starting at null, fine. And then we are also creating, we're saying that next page is this data set from page 1, fine. And then we are constructing something that's called API answer. And this is fetching the URL.
Yeah.
From the next page, like whatever we put here, okay?
So one idea for debugging that's useful, you can everywhere in your program, you can just end it and say return whatever, like return API answer.
So that should be this URL.
So, okay, okay, here. Let's just run those two lines and we know step by step. So next page is an address, right? This is the last line. This is what we get. API answer is the result of fetching this address. So this is us going on the internet at this address and seeing what's there. And what's there is this data that we see on the right side. It has count, next, previous, and results, all of those things. This is what we got from that address.
Right. Okay.
So the next thing we do, we just look at the results part of it.
Right.
Yeah, create this results. Okay. So now here is what we're dealing with. This is a list of 10 people. Yeah. Okay. And we, in order to find the highest person, we need to go over this list.
Yes.
So that's why, we use the for off loop.
So we take like every person from this list, which is called results, okay? And
so actually what we do, we go over them one by one. We look at the first one, and then we look at the second one, and then we look at the third one, and we go over like this until the list is finished. This is what for of does.
Yes, but now I'm at the if statement. And
yeah, so let's so here's how the algorithm works, right? it goes over people one by one. So the first person, it looks at it, and the question is, what should we do now? We have no high, we don't know about any highest person, and here's the first person that we see. So in that case, when there is no information about the highest person yet, then this person that we see is gonna be the highest person because we haven't seen anyone else.
Right.
So this is this condition.
Yeah.
And the other case is that what if we had a highest person so far? So what if we already seen Luke Skywalker and now we're looking at 3CPO? What should we do?
Mm-hmm.
We
We
should
have to
compare. Yeah, we
compare.
should. Yeah, then we need to compare if the highest person that we.
Okay. So in that step, we're just doing basically what we did like a week ago.
Yes, yes. Here we exactly the same thing. Yeah, I just wanted to make sure that we get it here. So do you see why we got the Darth Vader here?
Because it's the tallest person in
Yeah.
the one.
Yes, exactly. So this part of the algorithm is works fine. It works fine on the list that it has. The problem is that the list only covers the first page.
Right. But we can go with other URLs, or we
Yeah,
can change the number at the end of the.
yeah. We can. So my idea for this was to reuse the next URL. So was to take a look and see, okay, I got the API answer, and I'm gonna update the next page. I'm gonna say next page now is API answer next, and we're gonna pretty much repeat the operation for the next page. So if you want to repeat something again, that's looping, and now we don't loop over an array, we loop over resources on a different server. So we're gonna use the while loop, and we just need to say while next page is not null, right? If we have a next page to see, then we need to fetch it and we need to do stuff with it, right? So this is basically our algorithm. Like so initially we have a next page being the first page, and then we say while next page is not empty, is not nothing, then we need to do something with the page. And here's what we do: we fetch it, we set the next page to whatever was the next from that page, and we need to go over the results from that page. So we're gonna use that piece of code, that bit.
Mm-hmm.
So I mean, this thing you already know. This thing you know that it can go over the results and it's gonna update the highest person. So really, the new bit is running all of this in the while loop. So saying unless there is no next page, then I need to repeat the operation, but with the new value of the next page.
Yes. On this theoretical level, yes, it makes sense.
Okay, so yeah.
Oh.
Oh, interesting. So it didn't. So sounds like some person didn't have the height given. That's interesting. I wonder why was that. Okay. Let me see.
Maybe it was given in meters and it was like with a dot or a comma or something.
Wow.
I think
Yeah, interesting. Seems like we run into a different problem. Unable to convert given value to integer makes sense, but I wonder what was the value that caused the problem. So we need to do some debugging. So the question is which person caused this problem, because our program goes over all the pages and goes over every people in every page, but at some point it comes back with an error. Um, yeah. Mm,
I
indeed.
bet it's Wookie.
Yeah, maybe. Okay, so let's add a counter and see. Okay, counter equals 0. And this counter is gonna be increased every time counter is gonna be increased every time we take a look at another person. So here I'm gonna say counter plus 1. And now that I have the counter, I can use it to break my my program at a certain moment. So let's say if counter is over 20, then return.
Okay.
All right, yeah, return. Okay, return the highest person so far, so we know. Okay. Okay, so this got Chewbacca, but it only look at 20 people. If you look at 40 people, then you get the error. So interesting. So it happens between 20 and 40. So it happens between 20 and 30 actually. So 25, does it still happen? No. Okay, so 27. This is called binary search actually. As you can see, I'm not checking every number. I'm just figuring out where the problem is. And the problem is at 20 and the
So
27. Yeah, exactly. Let's see what happened there. Guy 27. Yeah. 26, 27. Height. Okay, this one looks fine. This one looks fine. Interesting. This one also. Oh, this one, you see? Unknown. Okay. 29 actually, yeah. Unknown. Yeah. Wow. So here's like, I mean, yeah, I did not expect to see unknown, but again, like you're integrating with another server which can pretty much like work as it wants to. So you're gonna see those things here and there. So in order to make our program work, let's remove the counter. We don't need that now, and let's just see if we basically need to have another condition here. If person height is not unknown, and
right.
yeah, and it's actually higher, then do this. And now, yeah. Okay. Yeah, and now the brackets again. How is this not a known operation? Oh, and yeah, I'm kind of confused, to be honest. Let me see. For okay. Okay, there is a different way to do it. I'm just gonna say if person height is unknown, is not unknown, then do all of that. So yeah, is not unknown, then so if person is not unknown and if it is the highest, then do this. Okay. It runs, it runs, it runs, it runs, it runs. Okay. Whew, this guy. Yaral Poof. Not sure which what planet is he from or what movie, but this is the highest one.
Well, that's surprising.
Yeah, yeah.
Yeah.
Yeah, but it took a little bit of work, especially like joining the pages here, this additional loop and and this bit that I was not expecting. But as you can see, we were able to do it, but it was just more complicated because we need to juggle through those pages, as you can see here.
Yeah.
Yeah. Okay. So yeah.
Well, there are definitely some new things for me to go through at least like 10 times more. But yeah. Mm,
Something for you to play with, I think would be very beneficial as some sort of homework. And to anyone listening, if you guys interested, would be to figure out like how many of those people have like white skin color, or how many of those are male, how many are female. To answer a question like this, it should be already possible using the like the mechanics, the programs that we wrote here, the examples. And I think I think that's very useful for training to see.
yeah. Like one more minute to answer the comments. So we have from Day, we have use spread operator. I don't know what that means, but
Right. Yeah, that's a good idea. Actually, the spread operator is something that is available in JavaScript, and not at least maybe not yet in AskScript. So in JavaScript, in JavaScript you can, yeah, here it's like, let me pull out the JavaScript console. In JavaScript, if you have a 1, 2, 3 and 4, 5, 6, and if you want to join those together, you can use the spread operator like this. Just create a new array and say, I'm now spreading this A bit into here, and here I'm spreading the B bit into here. So this is a way to join to arrays. But this is JavaScript. It's a different language, but just to,
okay.
yeah, give the context to it.
So
Yeah.
we got that. There is from Rami. We need a variable to hold the max height so far. I think we got that.
So yeah, that's a good point. So what we took a little bit different route here. We wanted our program to be more generic, so we just kept track of the person, which was the highest, not actually its height itself specifically, but the entire person object. So here we looked at the height property of the highest person.
Okay.
We didn't need that extra variable. We could just be saying, okay, here's the highest person, and if you want to compare it to anyone else, you need to look at its height property.
True. And then from Ryan, we have use Axios instead of fetch. AXIOS.
Oh, interesting. Yeah. So that's Axios is a library. It's a JavaScript library for fetching for like getting information from other servers for making requests. Here again, this is not quite JavaScript. It's a language that looks similar to JavaScript, but it's different. And the fetch here is our own function that we have built here, and you can see its source code. It's in the node folder called fetch, and this actually uses the node fetch library. So it works like fetch, but this is just a wrapped inside the AskQL technology. And the reason why we need this additional layer is to be able to run programs safely. Because again, like if I did something, if I made a mistake, and if I had like a loop inside my program that never ends, such as this one, is 2 plus 2 will always equal 4, and so that no, so this will never end, right? And it will say oversteps limit. If I was to do the same thing inside my browser, it would pretty much kill the tab that I'm on. It would not be possible. So we are creating a technology here that allows running programs from unknown sources. This is why we had to wrap pretty much all the operations inside additional layer that provides this safety and can say that, can run safely, basically.
Mm-hmm. One more comment from Rami: use max highest person current person in the square brackets. Max square brackets highest person current person.
I guess that would I would let me take a look at the comment. Actually, I'm gonna stop sharing and take a look at the comment. Who's max to call the max height of a person? Oh yeah, I see. Which one were you reading? Which comment?
The last one from Rami, and use max highest person current person.
Yeah, that's a good point. Yeah, okay, I got it.
And
that's a good idea, Rami. Thanks, because you're right. If you instead of doing that, you could just I guess here it would actually not work, because max is something that returns the maximum of 2 values, and we actually, in this step, we are not interested in the maximum of 2 values. We just need to know if the highest person is higher than the person we're looking right now, because we need to update the highest person in that case.
Mm-hmm. And the last comment is from Salem: use max to hold the max height of a person.
Yeah, that would also work. I just chose to use the highest person as a reference to the entire object instead of just holding the value. I mean, these are all great comments and great ideas, and I'm really happy to see so many. And we do it. Yeah, we're gonna keep doing this.
Yeah, and we also invite you all, right, to help us create some features, maybe, or maybe things like spread operator, right, and to submit pull requests. Is that correct, Martin?
Yes, definitely. This entire technology that allows you to run those programs and do it easily, because in JavaScript you would need to perhaps say await, and that would all be async and just like more confusing overall. If you want to help us build this technology, you're welcome, and you're gonna get all the support you need. And this is our repository. We already have like many interesting, exciting things to work on. Most of those are labeled with the like good first issue, for instance. We got 21 of those about like fixing different small things about the technology and the playground. so that we can do more things in the lessons. So everyone invited to help out.
Yeah, of course. So I'm being attacked by a moth. Like, can you guys see this? All right, so it's clearly time to wrap it up. It's a huge moth, like really big.
Yes, please don't harm it on at least while we're live.
No, no, I don't hurt animals, even bugs.
Okay.
But yeah, so thank you guys very much. And Dai, Rami, and Ryan, and Salem, you guys are invited to come check our documentation and check our repository on GitHub as well. If you want to participate and help us develop the technology further, then you are very welcome to do so. And we'll see you guys next week.
Yeah, and I mean, bugs are truly everywhere, and you can expect expect them always. That was awesome. Yeah, we're gonna continue with the API work on next lessons. Thanks for joining in.
All right. Thank you. See you next week.
Bye.